Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now, in our next question, this is actually a frequency modulation. So if they want you to find the frequency of the unmodulated carrier wave, now what do we do? Because the question gave you this. How am I supposed to find out the frequency of the unmodulated carrier wave? Because the problem is, in frequency modulation, I have already changed the frequency to this. So how would I know how the original frequency would have looked like? Because they didn't give me the original carrier frequency. So the technique is, you have to count the number of cycles, all right, in this diagram from a maximum compression to a maximum extension. Like for example, you will see that this part is the highest compression. If you compare all along the waves here, this is the maximum, this is one of the maximum compression, and this is one of the place with maximum extension. Now it will be symmetrical, as in this side will also be maximum extension. So there and here both will be maximum extension. So the theory is, if I were to count the number of cycles from a maximum compression to a maximum extension, then they would cancel each other's effect. As in, like, this was compressed, this was extended. So if I keep counting number of cycles as usual to here, then it will be the same as number of cycles in an unmodulated carrier wave. So like in this case, I can count from 0 to 4 because this maximum compression would cancel out the maximum extension effect. Or I could count from 0 to 8, okay, because after this 4, there's another maximum extension that can cancel this another maximum compression. Or I could count from 0 to 12 because then I have another maximum compression that can cancel this maximum extension. But what you cannot do is you cannot count the number of cycles from 0 to 6, for example, because this compression will cancel this extension, but this extension cannot be cancelled by this. It needs to be cancelled by here. So you cannot use 0 to 6. So if I use in this question from 0 to 4, I will be able to get how many cycles? 1, 2, 3, 4, 5, and then divided by 4 microseconds. So that will be the frequency of the unmodulated carrier wave. So the next one is to find the frequency of the information signal, which is something like this lah. Remember the diagram which I showed you. So in a if I want to find this frequency, normally I would find the period, which is from here to here, and then 1 over the period to find the frequency. But if I'm given this, what should I do? Now this highest point here, the peak, will correspond to highest frequency. This peak also will correspond to highest frequency. So I just find the time from highest frequency to highest frequency. That would be the period of the information signal, and then 1 over that. So like in this case, from the highest frequency to the highest frequency is 8 microseconds. So 1 over 8 microseconds will give me the frequency of the information signal. And then this one, if this is again frequency modulation, so this carrier wave is given frequency and amplitude. Now the carrier wave is frequency modulated by a sinusoidal wave of frequency 7 kHz and amplitude 2 volts. So actually, if this is modulated by this, then this is your information signal. All right, and the frequency deviation is 20 kHz per volt. So what does it mean, right? Now remember, the frequency of the carrier wave will change according to the displacement of the information signal. So for example, the 1 volt here per volt here is referring to the displacement of the information signal. For every 1 volt of the information signal, the frequency of this carrier wave will vary by 20 kHz. Example, if it's positive 1 volt displacement of the information signal, it will increase by 20 kHz. But if it's negative 1 volt displacement of information signal, the frequency will decrease by 20 kHz. Okay, now firstly, let's do this part. What is the amplitude of the modulated carrier wave? Now in frequency modulation, we will not touch the amplitude of the carrier wave. So if the carrier wave has an amplitude of 5 volts, its amplitude after modulation will still be 5 volts. Now what is the maximum frequency? Remember, this frequency will have to be varied by 20 kHz per volt of the information signal. So if your information signal has an amplitude of 2 volts, it means the maximum positive displacement is 2 volts. So 1 volt, the frequency changed by 20 kilohertz. So 2 volts, the frequency must change by 40 kilohertz. So if it is positive 2 volt, they will increase by 40 kilohertz. So your maximum frequency is 640 kilohertz. But what is your minimum frequency? So if the displacement time graph for this information signal, remember amplitude 2 volts means it will have positive 2 and also negative 2. So if the displacement is negative 2 volts, then the frequency here will decrease by 40 kilohertz. So 600 minus 40, you get 560 kilohertz. And then the last part, the number of times per second that the frequency changes from maximum to minimum and then back to maximum. So what does it mean, right? Which is the number of times per second the frequency of the carrier wave, right, changes from highest to lowest and then to highest again. Now, if we notice, right, from this diagram again, that they are asking how many times in 1 second will the frequency changes from highest to lowest to highest, all right, in 1 second, right? How many times in 1 second? So that actually, right, is related to your information signal, because do you realize highest frequency is peak, lowest frequency is trough, highest frequency is peak. So if the number of times it changes from maximum to low to minimum to maximum frequency is the number of times that the information signal changes from peak to trough to peak. So if they want the number of times in 1 second, which is the number of times for this to change to this in 1 second, it is actually the frequency of the information signal. Like in this case, if the frequency of the information signal is 7 kilohertz, all right, here, then it means that it changes, the information signal changes from peak to trough to peak 7,000 times in 1 second. So therefore, the frequency of the frequency modulated wave will change from highest to lowest to highest, also 7,000 times per second.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.